Good morning, everyone. I'm Shuta Olusegun. In today's video, we want to look at the constancy of light speed. Well, uh, Einstein got special relativity, and in special relativity, he was able to develop an idea, thought experiment, that if an object is thrown at somebody, well, the object will get to that person depending on how far the person is moving away from the object or how far the person is moving towards the object. So that will determine how quick or how delayed the object will reach the person. But Einstein now says that in the case of light, it is not so. That if a light is actually focused at somebody, or if a light is projected towards somebody, then the light will reach the person instantly. So irrespective of whether the person is moving away from the light or moving towards the light. So that is actually talking about the constancy of light. But now the main issue is, can we actually say that light is constant when it travels, when we have what some people might call what they might just call observers effect, or they just say in a situation where we have red shift or blue shift. So when we look at that, if the constancy, if light is constant, as we have been made to know, then must light be stretched? So to me, the way I see it as, if light is constant, then the constancy of light should be portrayed as Einstein said it, that even if the person is moving away from the light or moving towards the light will still reach the person instantly, irrespective of whether you are moving towards the light or moving away from the light. So what I'm trying to say is that the expansion of the universe shouldn't stretch light if light is constant. So that means no matter how far the light is in the space, like relative to the observer, then the speed of the light should reach the observer instantly. That's what I'm trying to say, that for light to really, own the title of that constant speed, then the constancy of light speed must always be constant and instant. So now we're going to use this diagram on the board to illustrate and to dissect what the constancy of light speed is. So now, if you have been watching my video, you'll be conversant with this diagram, which is time energy wave model. So we have energy wave right here. Energy travels inversely to time wave, and as a result of that, we have convergence of mass at the topmost region and the bottommost region. Now, based on the formula of everything, which is the T, the M, where we have capital Um plus 4M, we know that once we supply quantum mass worth, which is electron mass in this case, in the place of M and in the place of M here, we're going to get the classical counterpart, which is 2,277,250,000 kilograms. Now, this is the electron mass in kilogram. Now, by having this value, we can as well put this classical mass or this classical mass worth in the formula to arrive back at the quantum mass worth. Fine. But how can we now use this formula of everything to prove the constancy of light speed? Now, the thing is this: by supplying the mass worth in formula of everything, we actually get uh, this particular classical mass worth. Now, for us to get wave amplitude that we can actually use to construct this triangle that we have here, which is equilateral triangle, we need to supply the classical mass worth inside this in place of the m here. And once we do that, we're going to get this amplitude, which is 5.7 times 10 raised power 48. That is the value that we will get, and that value will actually extend that value which we have we actually extend this particular value. It will extend it, it will, this classical mass worth will extend the amplitude, wave amplitude, to the point where 4m's value, which is 9109, it will stretch it to the point where the 4m's value will be suspended to it. Now, what is that telling us? What we have here, since this formula is a linear formula, we can actually draw the mass worth diagonally as what we have here, and then the entitle of the zero suspension is 48 power. So we're going to actually have that as the wave amplitude, but in this case we draw a line to the point of the convergence, which is the classical convergence. Now the thing is, now that we have the arrow to this point, if we want to now annihilate all these zeros such that we get to the quantum level, because we are still at a classical level here, so we will now want to get to a quantum level, we will use this particular value, we will annihilate all these zeros, and once we do that, we're going to have, what we're going to have will be, so we annihilate like this. So these zeros, we have it being suspended at 32nd. So we have this value being suspended at 32nd zero. So now when we have this 9109 over then 10 raised power 32. So we're going to have it like this. And so if we shift this such that we have 9109, then times, it will now be equal to 1 over 10 minus 32. By cross multiplication, then we're going to have 9 point. So we have point here, 9.109. So by cross multiplication, we have 9.1, let me just say 1 times 10 raised power minus 32. Minus 32. So now the value that we have here is the corresponding value for quantum, electron mass. Now we shouldn't forget that the value that we have, electron mass value, is actually beyond the time energy wave model. And as a result of that, by traveling beyond, there is there is this energy. We're going to have a kind of collision, and in the process of that, there could be a process of energy loss or energy gain. But if you look in this case, electron is actually being extended, because the formula of everything is to extend energy beyond its limit threshold, such that the particles will be stable for measurement. So it is being extended beyond, to the point of superconductivity, and as a result of that, it is being thoroughly optimized, and so we have 9.109 times 10 raised power minus 32, so as our electron mass. So mass accumulation is dynamic, and that is why we could liken this phase to nuclear. Good. So now we will have moved from the classical level to the quantum level, which is even far beyond the time energy wave model. Now, for us to connect this point to have the quantum uh, wave amplitude, then we need to actually shrink this excess of electron mass back into the space, and by compressing to reduce this back into the space, we can actually compress it to this quantum wave amplitude, and as a result of that, we have another line connecting to the evolutionary singularity, and as a result of that, we have this triangle. Now, by putting this SS value into the small space right here, we actually energize the particle to travel towards the singularity of the future, and once that happens, then the triangle will be flipped, and by flipping the triangle, we have inverted triangle, which is a equilateral triangle. And if we sum 180-degree together with this 180-degree of the inverted triangle, we have 360-degree. If we extrapolate that, we're going to have circle, which results to the curvature of the wave. So basically what this is telling us is that the constancy of light is what we derived by having the linear trajectory of this triangle line, the vertical line, and then the diagonal line of the quantum uh, level. You understand? So now what we're trying to get here is, if you look at this, it is telling us that light can actually travel by uniform momentum. It can travel by uniform momentum, and once that happens, it is synonymous to what Einstein said, which is light reaching the observer at instant. So irrespective of the observer moving towards the light or running away from the light, so we have that constancy of light speed right there by having this triangle. So the constancy of light is actually embedded in the wave pattern of time energy wave model. Now the issue is, when we look at this region, we can see that the energy is being stretched, and once, because the formula of everything that we have has actually extended energy beyond its limit threshold, but the stretch is still within the range of time energy wave model. And for us to see how much that is being stretched, we can actually we can get that from the mass worth of electron while in motion, which is what we get if we supply this wave amplitude in this formula of everything. We get the mass worth of electron while in motion to be 0.000000001423. So you can see that that mass worth is so tiny, far tiny than far tiny compared to the mass worth, the actual mass worth of electron that we have beyond the limit. So now, by having light being stretched like that, because energy is inversely related to time, and light, as we know, is a pure energy, is an energy. So that is why light could be stretched as such. And so by having that stretch effect on the light, then we have the red shift. So at this region, we're going to have that red shift, which is the difference between the red shift will now be the difference between the limit of the light speed to the stretched point. So that's what we're going to have. And it is for this reason that when you look at the black hole, you have red light surrounding the black hole, because energy is being stretched around the black hole. I don't know, maybe it is the region of event or horizon or so. So that energy that we have around that black hole is so much stretched, and so we have red light. So that is the reason we have the red light here, indicating, and the red light is actually pointing out that that there is expansion, which is far more than what the constancy of light uh, can sustain. That's what the redshift is telling us. Then we shouldn't forget that right here, energy is being contracted so as to generate radiation to support the expansion of mass accumulation, which is what we have in the past region of this triangle. So now, the moment this triangle is being flipped towards the future singularity, then don't forget that this region has become the past for uh, the future singularity, and that is why we can have that red light around the black hole. So the blue shift of the light will then be towards the singularity of the future singularity or the black hole. So now what that is telling us is that based on the differences between, or let me say, based on the difference between the past and the future, we can determine the trajectory of light. You understand? We can get to know the direction at which light, or the direction towards light, is traveling to. So if we use the example of, if like a baseball or a golf ball, if that ball is being kicked, now the moment the ball is lifted into the air, then the ball is actually traveling through the past. We shouldn't forget that the ball that is being kicked at the present phase, and this is to tell you that the present that we have is a combination of the past and the future. So when the ball is kicked such that it is lifted from the ground, it travels through the past phase, and then the whole past phase will accumulate more mass to the ball. So when that ball reaches the point, the maximum point, that now serves as the present moment for the ball trajectory, and then the trajectory will be converted to the dropping momentum. So then the ball will start be moving towards the earth, and that phase we tag future phase. So in that phase, the ball will then be lighter than it is in the past. So the ball will be lighter compared to, because in that future phase, the ball will be decaying gradually, but we will not be able to see the effect of the decay. So instead, we see we see the effect of weight loss instead of decay, while we see the effect of weight gain in the past phase, but we have weight loss in the future phase. So basically, what this is telling us is that uh, universe usually use weight gain then weight loss to 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 actually traverse the universe. So the weight gain will determine how far the particle will travel towards the time region, while the weight loss will determine how far the particle will travel towards the energy. So basically, this operation is synonymous to what analog computer uses in defining the what is it called, the AI movement for self-drive. So analog usually add weight to determine how the steering will be how the steering wheel will be moved, and weight loss to other direction. So that is going to be a perfect way to achieve AI of self-drive, unlike what we have for digital, which is having more information. For a car to actually drive by itself, you have more information than necessary. And basically, the next video I will talk about the invention of time technology, and I'm going to talk more on how we can actually model the universe the way it is to achieve that time technology. So in the time technology, there is going to be conversion from digital to analog, then from analog to digital, but it's going to be more of analog. So we're moving back to the wave pattern of the universe, so as to have it well modeled just the way it is. For instance, let me give you an example of what I mean by saying that analog system is more suitable than digital system when it comes to time technology. Now, when you look, if you want to, like, something that could prove the combination of the past and the future in the present, when you look at yourself through a water or through a mirror, you see an inverted version of yourself in the mirror. That inverted, the way you see it is that when you look at your own image, you are from left to the right, but the image in the mirror will be from the right to the left. So it is being inverted horizontally, which is the same thing as this triangle that we have, that is inverted horizontally towards the singularity of the future. But like in the projector that when a projector projects onto an image, the image inside the projector is flipped upside down. So we rearrange the image to have, we rearrange, like when light enters into the projector, the image that we have, which is upside down, is not really upside down inside the projector. It is down up. It is being flipped down up, but we rearrange the information such that we have it the way we have it. So why is it that it is being flipped like that? It's because the flip is of the present, which is you have the past right here, and then you have the present right here. So we're going to, in my next video, I will talk more on what information is all about, but right now I think we get the picture, which is light has that constancy in its speed based on the formula of everything. When you draw the triangle, you can see the constancy of the light speed, but the redshift that we have is telling us that there is possibility of faster than the speed of light. And when energy is being stretched beyond its limit threshold, we have the effect of redshift relative to dilated time. And that is what relativity is all about. So relativity is a powerful concept. So relativity is telling you that when time is dilated, then you have length contraction. So basically that is what we have right here. But the system of mass accumulation is far beyond what human can really comprehend, because the energy is being contracted as it expands relative to time dilation. So that is that. So I believe this video is quite insightful and informative. If you like the video for real, make sure you like the video by clicking the like button, then share the video with your friends. Don't forget to subscribe so as to be notified for the subsequent video. And you shouldn't forget that this is a novel discovery, so I'm going to put a link or links to my research publications in the description below. You can click on it to explore the formula of everything and see how it works and how it dissects the reality of the universe the way it is. Thank you. God bless you.